Okay, in this problem it says the force for n is equal to the force for m plus some additional amount for the first year and just equal to m after there. And we're given the complete expectation for m and we want to know it for n. So I just started with the ratio of the two, and I'm going to use recursion because I know that n is equal to m 1 year later. So anytime you think something's equal to something else or related to something else 1 or 2 years apart, think recursion. And so for the numerator, I say if you live, then you get 1 year plus your expected future lifetime. And your expected future lifetime is the expected future lifetime of a 26 for m, because the force at n, or the force for n, is equal to the force for m at ages 26 and above. So that's why I put the curtailed expectation of life for 26 for an m-year-old when I was doing the recursion for the n-year-old, or for n. Then for m, it's the same thing. If you live, the probability of that is p25 for m. You get 1 year plus your future expectation. Now these two values cancel, and I'm just left with the probability that a 25-year-old for type n divided by the probability of a 25-year-old for type m. And then to find these probabilities, I'll just use what we use all the time. I add up the forces from the beginning age to the ending age, take the negative, take the exponential. So now for n, I have to use this force here, this first line, I'll highlight. And for m, I use the force for m. Okay, so I have for n, I have the exponential of the negative integral from 0 to 1 of the force for m plus 0.1 times 1 minus t, all that dt. And then the denominator, I have this. Well, when I take the exponential of two things, I can do the exponential of this times the exponential of this. And so these exponential of the negative integral from 0 to 1 of the force for m is going to cancel. And I'll just be left with the exponential of the negative integral from 0 to 1 of 0.1 times 1 minus t dt, which hopefully you can take from there.